Hi, we're talking about long form and short form data and how to make an ANOVA in Sheets. So I'm showing you now my short form data, which is also called wide form. This has a column for each of the different levels of the independent variable. So this can be bleach, hand soap, hand sanitizer, dirt, whatever. That would be your different levels of your independent variable. This is the thing that you're changing. Now, in long form data, we don't have 5 columns for 5 levels. We have one column that says level. So that's why long form data can get really long. So we have trial 1, 2, 3 for each level, which would result in 15 rows in the long form data instead of 3 rows. So you can see that I enter level, each level 3 times, 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on. And then I'm going to do trial 1, 2, 3, 1, 2, 3, 1, 2, 3, so that we still have level 1, trial 1, level 1, trial 2, level 1, trial 3, for example. So here I have highlighted in the wide form data the result for the first trial of the first level, which is level 1, trial 1. And that is still going to have its place in the long form data table. They'll be right here. So we have level 1, trial 1, and there's your result. So we'll have the same for level 1, trial 2. It'll be right underneath it. So that's nice and easy for copying and pasting over, because we can really grab that entire column and paste it here next to level 1, 1, 1, trial 1, 2, 3. So we'll go ahead and do that. And so we can do that with each of these. Each of these columns we'll copy and paste and we'll stack them below. So as we have level 1, 1, 1, then we go down to below that is level 2, 2, 2, trial 1, 2, 3. Then below that is level 3, 3, 3, trial 1, 2, 3. And so on. So these are 2 ways of organizing your data. It's important to be able to do both, and it's important to be able to go back and forth from one to the other. Okay, so I've added some numbers. So we can make some graphs and do some stats with it. So if we want to make a graph, Sheets needs it to be in long form. So that's what we're doing right now. We are grabbing the data that we are going to add to our graph. And we are also grabbing the titles of the columns that contain that data. So this is categorical. I know it's numbers, but sometimes categorical can be numerical. And these numbers are just arbitrary. These are just different levels of a categorical independent variable. So what I'm going to do is I'm going to make it make a little more sense by naming these. Instead of having numbers, we can name them cat, dog. Let's just throw some nouns in there. So now let's grab those columns again, and this time it makes a little more sense. We've got our categories highlighted, and now we are going to highlight our results. I forgot. Let's grab the titles of the columns as well. So now we have our independent variable and our dependent variable only. And we are going to use these to make a chart. So to do so, we have them highlighted. We go to Insert, Chart. And Sheets gives us something automatically, which is great. But we have a line for every data point. So we want to hit Aggregate, and that will give us, in this case, it's giving us a sum of the data that we have. So what we actually want is a mean or an average. So we're going to change that to average, and then we are going to have our graph. So there are some aesthetics that you may want to change on your graph, definitely. And it's pretty intuitive. You can just click on the part that you want to change and change what you will. That's going to be in Customize. If you go into chart style, you can choose different colors for your border, for example, your background color, font, everything. But what we need to do is go into series. So this is where we are going to add, we would add error bars or a trend line if we were making a line graph. You can label your data, but we're not going to use any of that because we have a bar graph, and our stats are going to be an ANOVA, and that is not available to us in Sheets. So what we really need to do is we need to go and add an extension. So if you go into extensions and add-ons, you can get an add-on. And what we are going to get is XLM or XL minor. You can type that in, and it comes up just after XL. It's the second one there. And there it is on the left. XL minor. That is a great tool for doing stats within Sheets. So click OK, continue. They'll ask you for permission. And it's done that fast. So now you can just close that out. Extensions, there it is, XL Minor Analysis Tool Pack, and then you'll click on Start. And there it is on the right. So for this one, it actually does not like long form. This is why you need to be able to go back and forth between long and wide. So we're going to use wide form data. And we're going to do a single factor ANOVA. That's the very top one. Why single factor? Because you had one independent variable, so one factor. We have 5 levels, but still just one factor. So we choose our input range. This is the first thing we do, and we want to include the titles of the columns. We don't care about trial, but we do care about the different levels. So we have 5 different levels. Remember, that's cat, dog, mouse, fork, whatever. And those go from B2 to F5. So that's where our data resides. Now there are 2 options here, group by columns, group by rows. So the levels each are their own column. So we're going to group by column. And the labels are the column titles. So that would be the first row. And so we're going to say, yep, labels of these columns are in the first row. And now our output range, we just choose a place to have the output print out. And so I'm just going to go right over here, give myself some space, and the very top left of the output is going to be I2. So I'm choosing that little square, and there it goes. I2 is where ANOVA single comes out, and this is your ANOVA. So the one thing that you really want to look at, most importantly, is the p-value. That's what you're going to report when you say, yes, there are differences amongst these bars or these levels of my independent variable. You're going to put parentheses, p-value equals such and such and such. When you have a p-value that is this small, which is fantastic, even though this is fake data, then you report it as being p is less than 0.001. If it were higher than that, but less than 0.01, you would report it as being less than 0.01. And if it were between 0.01 and 0.05, you would say it's less than 0.05. And if it's 0.05 or greater, then you just report the actual p-value. So that is how a p-value is reported.